Some of them maybe.
I guess we can say let's take a break after an hour.
Yeah,
Anyways,
that's a good way to do it.
or an hour and 15.
Yeah, even if you're still going. All right, we're all over here, ladies and gentlemen. Okay, so as was communicated to us during the summit, there was a need to have more technical and more working sessions. And so that's what this afternoon is. It's the feedback we got from you that you wanted to have sessions where you get your hands dirty in the real nitty-gritty technical details and get some work done at these workshops, because they are workshops. So that's what we're going to do this afternoon. And we had these 6 topics that people had made note to us that they wanted to work on this afternoon. And I'll just have a call out now. Is there anything someone else has thought of that they would like to tackle this afternoon? Seeing nothing, we'll start with these. Now, for Mojo Networks, is that, do you feel like that's been taken care of, or do you want to continue the discussion? Okay. Okay, so yeah, that's what we'll do, is we'll combine the top 2. They're both based on ONI and security, although they're different parts of that aspect, but we'll combine those into 2. So what I'll ask each of the breakout leaders to do is to come up and give you like a 5-minute tops introduction about what they want to cover, what they're planning on accomplishing during this topic, and that'll give you an idea of which ones you want to plan to go to. After we're done with that, we'll kind of do hopefully a little scheduling where we can figure out where each session will be, each breakout will be. They won't all be in parallel. There'll be some that we'll do serially, and so you will be able to go to more than one. And we'll also gauge interest to figure out, can it be in a smaller room versus a larger room. So Kurt, can you come on up and talk about the secure boot for x86?
Sure. So right, as Murthy introduced earlier, there's a lot of security to talk about in ONI. And so if we combine those sessions, we can talk about that. And then what I was going to talk about was how the security primitives and things that we can do for x86-based platforms, which involves like UEFI, secure boot, and how to use TPMs and things like that. So I see us discussing, doing some brainstorming, what are the problems, what are we trying to solve, how can we solve them, and then moving on into some details of nitty-gritty stuff, some perhaps how do we implement them, what does it mean for the build system, what would it mean for hardware vendors, things like that. So that's a quick overview.
Thanks, Kurt. So, Dawn? Hey, there you go. Did you want to use slides?
No, don't need the slides. But I'm going to take more time than Kurt did. Just some of you may not know what OOM is, so it doesn't mean out of memory. Dustin told me a year and a half ago it's a lousy name for a project. Linux people know OOM is out of memory, but it's Open Optical Monitoring. So I'm working for Finisar, right? We make SFP, QSFP, CFP, things like that. Those devices have EEPROMs on them, and that EEPROM has lots of useful data that we'd like to make available to data center operators. To get that data, you got to get it out of the switch, through the NOS, up into the user space, and decode what the data means, and it's all in obscure, strange formats. There's lots and lots of data, hard to get at. So I have developed a software layer called OOM. It's an OCP networking project, an official project. It's got a GitHub site. The code's all implemented. And you can basically go there, download a Python package that will decode 200 different keys from your QSFP device or your SFP device. It knows how to find them. It knows how to decode them, provides the data. You say, use this package, give me a list of ports. For this port, give me the temperature, and you get back a floating point number. Literally 3 lines of Python to get a floating point number of the temperature of a particular device on your switch. Okay, so that's what it is. We put that all together. It works very nicely. It depends on the drivers underneath it, and it turns out those drivers are very, very in quality or very in capability by a lot. So today's topic is the drivers in the Linux kernel that provide that data. Right, I need to be able to read all the data in those devices. I also need to be able to write some of the data in those devices. So some drivers don't provide write access. Some drivers don't provide access to enough pages, and virtually none of them provide access to as many pages as I'm going to need. Right. So right now with write access, I can do things like turn off transmit disable by software. Or I can do transmit disable with software. I can basically write it to do that. I have other features that Finisar provides that do things like I can make the lights flash on the device at both ends of the wire from my control console. So the pull tab on your QSFP will start flashing under software control, as well as at the other end of the cable, that light will start flashing. We're developing capabilities to be able to read the data from the far end device. So for instance, as a switch operator or a network operator, you're controlling all your switches, but you would like to know how the QSFP device in the server at the other end is doing. You don't need to install software on the server. I can reach into that through the network, through my QSFP devices, and get that data back to the operator. To do that, I need to access more pages in the EEPROM, which none of the drivers we have right now do. When QSFP-DD comes along, we're going to be able to access pages that aren't defined in the spec for QSFP right now. That spec says there are pages up to page 3. We're going to need to go beyond that because QSFP-DD is going to have 8 channels instead of 4. There's enough room in there for all the data for every port, so we're going to have to put that data in higher numbered pages. So the topic is how to get a driver that supports more pages, supports writes, gets it universally adopted across all the NOSes that OCP networking supports, so that we can have all these capabilities. And actually, we have a driver that does all that. I'd like to talk even deeper about how we do things like naming, distribution, where you get your driver from, and how it propagates through the pipeline, and things like that. So a lot of, as Kurt said, nitty-gritty little details about the driver for whoever's interested. Who's next?
So next up is Chinlu from Microsoft. And I put SAI and Sonic. Is it just Sonic? Oh, it's both. Excellent.
Yeah. This is Xin from Microsoft. I'm presenting the Sci and Sonic community here. So interestingly that we saw a lot of new faces in this room. So in the afternoon, we will begin with an introduction of what is Sci and Sonic. At a very high level, it is a modernized open source switch OS, which make the laser focus in the cloud scenarios and containerize all the components so that it's easy to operate, maintain, and upgrade, as well as enable you to take advantage of hardware innovations. So in the afternoon, besides the introduction of these 2 projects, we will also update everyone on the development of the last 6 months, what we have been doing, and what's the progress in the community and the protocol development, as well as I just attend an open source community meeting in China, update what's going on in China and how they are going to support Sonic in that market. Welcome to our session. Thanks.
Okay, thank you. And then next is Bill, who has a substantially less technical session.
Actually, I'm not going to speak at all. I want to listen. Oh, sorry. Yeah, there we go. Yeah, I just said I don't want to speak at all. I want to listen. We've disaggregated the switch. We have all the ingredients. The software ingredients. We have a wonderful portfolio of switch products now. We're looking at access points and so on. I'd like to understand what challenges you see in adoption of these products and understand how the foundation can help overcome some of those barriers. And so It's really to understand, you know, what you're seeing out there as adopters. If you're an adopter, a user, understand, you know, how that, you know, what barriers you have within your company to deploying these open hardware switches and open software stacks. If you're a supplier, understand and share your, you know, barriers that you see, and really understand what the foundation can do. You know, is there a segment of members that we should, you know, be targeting to bring into this community and really overcome those barriers to adoption. So, by the way, Omar, if we wanted, we could actually, you know, combine this with the next section. We could do, because we want to talk about project scope. This may affect how we scope the networking project as well.
So Omar and I talked, and I think what we're going to do is that last one is applicable to the entire project, right? It's our scope. It's for everybody. So at the end, I think we'll reserve a half an hour or 15 minutes or whatever we need to talk about our project scope and where it's been and maybe where we're going to go. So I think we can do that as a group.
Do both those as a group?
At the end.
Or you still want to have a breakout?
Do you want to do a breakout?
It's up to you.
Let's gauge some interest. Let's do that. So if you take out the first one and the last one, we have 4 breakouts. Let's vote for 2. So everybody gets 2 votes. And if you would like to attend the first 2, is basically the ONI Secure Boot and ONI Security on x86 devices and ARM. Raise your hand. All right, keep 'em up, keep 'em up. All right, we got about 8 to 10. All right, and then the pluggable module driver for OOM. A little bit more, and if I'm seeing this right, they're disjoint groups. Okay, then the Psi and Sonic for Microsoft. Okay, lots and lots of interest there. And then the OCP hardware and software adoption challenges. And great, so a little bit smaller. Gotcha. And
Psi and Sonic did overlap. It looked like there was some overlap between OOM and Psi Sonic.
oh, okay.
I couldn't quite tell.
That makes sense. So actually, I think if I saw this correctly, what we could do is we could break out the first 2, so the ONI 2 and then the OOM, and do those in parallel for about an hour, and then see how everybody's doing. If you're sick and fed up with that topic, we'll move on to other topics on here, or if you want to keep going, then you can keep going on those topics. But let's plan for 1 hour, and I think the OOM had a bigger, so why don't we do OOM here?
Just getting a sense, did everybody have a vote for one of those 2, or did you want to run a third one, Psi, Sonic in parallel? I'm trying to get a sense. Do we want 2 or 3? We have 3 hours, right? So initially we were thinking, you know, go for an hour with one and then kind of do Psi or do another 2 for the next hour and a half. Or if people really want to go for 3 hours on one of those topics. Yeah, that was one possibility. If we think Psi and Sonic has enough to go, because that was probably the biggest of the groups, and if that has enough to go for a full 2 to 3 hours, we could just run that as a third track in parallel.
It's around 1 hour, 40 minutes to 1 hour.
Oh, you think it's probably more like an hour discussion?
Yeah, it's around 1 hour. It's
Okay.
not too long.
Okay. Well, then let's just stick with the original 2. Let's just split up ONI and OM. And then we'll come back after an hour and then start Psi and hardware software adoption.
Okay, so we'll do the OOM here, starting now, and then let's say in that conference room in the corner there is called Act 6, and we'll do the ONI topics in there. The for anyone who's remote. There it is. So Act 6, this is the link that you can use to dial in with Blue Jeans, and that's all set up in that room, ready to go. Here, you can just stay on the feed that you're on if you're remote. So go ahead and move to whichever topic you would like to focus on. And after an hour, we'll kind of gauge the level of where everybody's at and readjust.